I found this Blender shader by another creator, and it inspired me to create my own version in Three.js, because I'm working on a game for the browser. The problem is though that I barely know anything about VFX, which I definitely need to get familiar with if I want my game to look good. Before this, my only experience with VFX was what I learned to style this globe for my last video, where I made the particles float and glow. I want to get familiar with textures and UVs, and this project was definitely a good way to do that. So here's what I learned about VFX for game development by creating this stylized flame shader using React 3 Fiber and TSL. I'll cover how it works, how to build it, and how to compose the scene to make it look good. And then I'll go over the core principle behind this effect, which is actually the same principle behind many different types of effects used in games, so that after watching this video, you'll have an intuitive feel for how to create all kinds of visual effects that you might find or imagine. Here's what we're going to make. It's a stylized or unrealistic flame, where you can control the amount of flicker, adjust the shape and placement, change the colors, adjust the amount of fog and glow, and I'll show you a trick for the looping animation so that it doesn't really look like it's repeating. As always, you can follow along while playing with the shader yourself by following the link in the description, and you can get the source code from my Patreon. Starting from a blank canvas, where do you even start? Let's begin with the shape, something like an icosphere in Blender, but now we need to make it move, and that's going to be a little bit more complex. What would I do if I was using Blender? Well, I'd use a displace node, which takes a noise texture and uses it to displace the vertices of a mesh. So that's the effect that we're going to code ourselves, a simplified displace node. If you're more experienced in the technical side like me, you might be tempted to write your own function for generating the noise texture, and I did that, but I wouldn't recommend it. I even ended up deleting my noise generator because you'll quickly realize that for these kinds of creative applications of math, you're going to want quick visual feedback. And instead of reinventing a full-featured noise generator, you can just use a free one that already has all the features you need, like the one in Blender, or this neat site I found called Effect Texture Maker. I looked at the source code of Blender's noise generators and compared it to some simpler implementations that I considered, and it's obvious to me that they've put in much more work than I'd want to spend time redoing for the sake of this small demo. So we have our noise texture, and believe it or not, I used these tiny dimensions and it still looks good. Now we're going to use this texture to displace the vertices of our icosphere along the normal direction. But how do you adjust the amount of distortion? We're going to multiply the displacement amount by a scale factor, and optionally you can connect it to a slider. But a sphere isn't a good base shape for a flame, so I added some code to stretch it into an egg. In Blender, I would just use the grab brush or proportional editing, and I think that's the better way to create your own base shapes, if they don't fit neatly into one of the Three.js primitives. But for this, I used code. I pulled the vertices of my mesh to a specific point above it, with the pull strength determined by a falloff factor, so that vertices near the top are strongly affected, and vertices near the bottom are completely unaffected. Flames are static, so how do we animate the shape? For that, we need two things, time and the UV mapping. UVs are coordinates that specify how to map our texture to the mesh's vertices. If we adjust the mapping of the UV coordinates based on time, we can animate our displacement. So I added time to the y-axis, and now it scrolls vertically, and multiplied it by -1 to change the direction, so that it goes from bottom to top. You can also do things like create a mask to change the amount of displacement based on the vertical world position of the vertices to make one side experience more distortion than the other. And that's our displace node. The code is quite short, and you should now be able to understand exactly what each piece does. Our animated egg is interesting, but it's definitely not a flame, so let's address that by putting a texture on it. To create that, I'm using Photoshop, but any graphics program will do. Krita is free, for example. For my texture, I'm going to create an oval, fill it with a gradient, and save it as a PNG with a transparent background. That's all we need for my effect, but check out the video I referenced to see how you can get different results by being creative with the texture. Back in the codebase, let's create a matcap node to put the flame texture on the mesh. The node does two things. It maps the normals in view space to UV texture coordinates, and it sets the color and transparency by mapping black and white to colors we select. Once we connect the custom nodes to the material and set up the sliders, we have our flame. If you stop here, you might notice that your scene looks a little bland or amateur. So we're going to add 3 things to our scene to make it look good: fog, bloom, and a trick to make the flame's animation loop more random. Because Three.js comes with fog and bloom, I thought this was going to be easy, but then I noticed two major problems. The bloom threshold is a hard cutoff, a straight line with no transition, and unlike game engines, Three.js doesn't have vertical fog. Luckily with TSL, we can tweak things, so that means we have to go back to the code. Let's start with the fog. Three.js comes with two types of fog, linear and exponential. For this scene, I preferred the look of linear, but exponential is supposed to look a little more realistic. So for our custom fog, I'm going to make two nodes based on the linear implementation. One fog for the XZ axis, and one for the vertical Y axis. For a subtle aesthetic improvement, I used smooth step instead of a linear curve, and then I combined the XZ and Y fog to get the final output. Wrap it in a hook that's passed to the scene's fog node, set up the sliders for the near, far, and height parameters, and we're done setting up our fog. And now for the bloom. I really want to make the transition smooth and get rid of that straight line. How do we do that? I'm going to reuse the built-in bloom effect, but we need to pass it a custom mask to tell it which pixels should glow. We want the effect to be applied based on luminance, which you can calculate by using these weights for red, green, and blue to get the brightness based on how sensitive our eyes are to different colors. Then we create a mask based on that luminance with a buffer around the threshold value using smooth step to create a soft transition. Send the soft mask to the built-in bloom effect, and add the output to our scene texture, set up the sliders for controlling the bloom parameters, and we're done setting up our glow as well. The scene looks good now, but the flames animation is a little too repetitive. Thankfully, there's a very easy way to solve that. Since our flame looks different from different angles, we can just spin the mesh at a speed that's different from the loop length, and now it looks much more random. As mentioned earlier, you can check out the flame from the link in the description, and you can get the full source code from my Patreon if you want to see how I set up the full React project. At this point, our scene is complete, but more importantly, we understand all the different pieces that go into creating VFX. The core principle being UV scrolling, or the idea of taking a texture and animating its mapping to a mesh to drive various parameters. For this project, we used a noise texture to drive mesh displacement. But there are all kinds of effects you can create with this same principle, like attack trails, radial explosions, and so on. Until I finished this project, tutorials by professional VFX artists didn't really make sense to me, but now that I've taken the time to implement each step on my own, I feel like I know how to approach any kind of effect that I might need for the PvP sword fighting action game that I'm working on. If you're interested in that, check out my devlog series, which is available on the channel. For the next episode, I'll be working on weight painting the 3D models I created. Subscribe for more videos on the art and code of game development, and I'll see you next time.